everyone, welcome back to my channel Tutelage, a guide to economics. Here this is Triparna. Hope all of you are doing good. We had discussed already how to calculate the arithmetic mean by direct and shortcut method, and which is in discrete series. If you have missed my previous session, please go and check my description box and my first comment where the previous session link is already shared. So learner, let's begin the session and move on the next slide, where we can see the today's topic for discussion. The first one is again the formula of the arithmetic mean. The second one is the calculation of the process of arithmetic mean, which is done by the direct and shortcut method, but which is in continuous series. Okay, and now go to the third part, that is the weighted arithmetic mean, and last but not the least, that is the merits and demerits of the arithmetic mean. So, learner, let's start the session and move on the next slide. So, here we can see the basic or primary formula of the arithmetic mean. So, arithmetic mean of a set of n numbers x1, x2, x3, x4 xn is defined as which is denoted by x bar equals to x1 plus x2 plus x3 plus plus xn, which is divided by n. That means summation x by n. So, n is equals to the number of observation, okay, and x1 x2 xn denotes the n values of a variable. So, now going to the next slide. Here we can see the calculation of the arithmetic mean in the series of continuous observation, okay, and which is done by the direct method. So, now going to the formula. So, formula is equals to summation f m divided by summation f. So, in the case of discrete observations with frequency, so arithmetic the formula of the arithmetic mean equals to summation f d divided by summation f, and here summation f m, which is divided by summation f. That is the basic differences between these two formula of the arithmetic mean, where m is the mid value. Okay, so now going to the next slide. So, here we can see the four column. Okay, so first one is the variable x. First column basically denotes the variable x. Second one is the frequency. Third one is the frequency into m. M means mid value. So, value of f, which is multiplied by the value of m. So, at first we have to calculate the mid value or m. So, now going to the calculation. Okay. So, how we calculate the mid value? So, for the first class 0, the lower class limit plus upper class limit, which is divided by 2, that is equals to the formula of the mid value. So, lower class limit for the first variable, that is equals to 0, and the upper class limit for the first variable, that is equals to 10. So, 0 plus 10, which is equals to 10. Okay, so 10 by 2, that equals to 5, and which is the mid value for the first variable. Now going to the second one. So, 10 plus 20, which is divided by 2, that means 15. Now going to the third one, 20 plus 30, which is divided by 2, that means 25. And now going to the last one, that is 30 plus 40, which is divided by 2, that means 35. I think this is clear what is the calculation process of the mid value. So, mid value is equals to lower class limit plus upper class limit is divided by 2. There is a basic differences between the calculation of the assumed mean and calculation of the mid value. So, for in the case of assumed mean is equals to the maximum value plus minimum value, which is divided by 2. In the case of mid value, the lower class limit, because it is a continuous series, continuous observation. So, that is why there are two class limit. There are two class limit, lower class limit and upper class limit, and that is why the mid value is equals to lower class limit plus upper class limit, which is divided by 2. I think this is clear, which is the calculation process of the mid value. And now going to the third column, where we can calculate the FM. that means f into m. So, f for the first class f is 2 and mid value is 5, that equals to 10. Now, going to the second one, that is 2 and 15, that is equals to 30. Go to the third one, that is 4 and 25, that equals to 100, and now going to the last one, 2 into 35, that equals to 70. For the formula, we have to calculate the summation Fm. So, summation Fm means summation of the all values of Fm. So, from the table we get summation Fm equals to 210 and summation F is equals to 10. So, for the formula, x bar equals to summation Fm divided by summation F, that means 210 divided by 10, which is equals to 21. So, 21 is the answer of the arithmetic mean. So, now going to the next slide, where we can see the calculation of the arithmetic mean in a continuous series with frequency, and which is done by the shortcut method. So, now going to the formula. So, formula of the arithmetic mean is equals to a plus summation fd by summation f. So, we all know that a for assumed average mean, f for frequency and d for deviation, and we have already explained the whole calculation process of d. Okay. Now going to the next slide. So, here this is an example and which is done by the shortcut method. Okay. So, now we can see there are 5 column. Okay. So, the first column indicates the variable of x, the second column indicates the frequency, third column indicates the mid value because it is a continuous series, and now going to the fourth column which denotes the deviation value, and now going to the last column, and where we can see this column indicates the multiplication value of the frequency and deviation. Okay. So, now going to the first class. Okay. So, we have already known that what is the calculation process of mid value. So, learner, how we calculate the mid value? So, mid value is equals to the formula of the mid value as the upper class limit plus lower class limit, which is divided by 2. So, for the first class, we can see there are 2 class limits. The first one, the lower class limit is 0 and the upper class limit is 10. So, 0 plus 10, which is divided by 2, that means 5. Now, going to the second one. So, 10 plus 20, which is divided by 2, that means 15. 20 plus 30, that is equals to 50. 50 by 2. So, that is why the mid value for the third variable that is equals to 25, and now go to the last one, 30 plus 40, which is divided by 2. So, 70 by 2, that means 35. I think it is clear for I think it is clear what is the basic calculation process of mid value. So, now going to the fourth column. So, D equals to small m minus capital A. Capital A means assumed average mean. Okay. So, now going to the calculation process of assumed mean. So, we all know that the formula of the assumed mean is equals to maximum value plus minimum value, which is divided by 2. So, here we can see there are 4 mid value, and where 5 is the minimum value and 35 is the maximum value. So, 5 plus 35, that is equals to 40. So, 40 by 2, that is equals to 20. So, 20 is the assumed mean. So, now going to the fourth column for the calculation of the deviation value. So, for the first variable, the m equals to 5 and a equals to 20. So, 5 minus 20, that means minus 15. Now, going to the second one, for the second class, the mid value is 15 and the assumed mean is same as 20. So, 15 minus 20, that means minus 5. And now going to the third one, so mid value is 25 and the assumed mean is 20. So, that is why D equals to plus 5. And now going to the last class, where the mid value is 35 and assumed mean is 20. So, here we can see the deviation value for the last variable, that is equals to plus 15. Clear? Okay. So, now going to the fifth column, where we can see the multiplicative value between frequency and deviation. Okay. So for the first variable, f is 2 and d is minus 15. So that's why f into d equals to minus 30. Now going to the second one, 2 into minus 5, that means minus 10. Going to the next one, 4 into 5, that means 20, and now go to the last one, that is 2 into 15, that means 30. Okay, so now going to the next slide. So in this slide, from table we get summation d equals to 10 and summation fd equals to 10, and we have already known summation f is equals to also 10. So now going to the formula. So what is the formula of the shortcut method? So that is a plus summation f d by summation f. So what is the value of a? That is 20. And what is the value of fd? That is equals to 10. So 10 and summation f is equals to also 10. So 20 plus 10 by 10. 10 by 10 means 1. So that is equals to 21. So 21 is the answer of the arithmetic mean, and which is same as the previous one. Okay. So now going to the next slide. I think this is clear. Here we can see the types of arithmetic mean, and we have already discussed that portion, what do you mean by a simple arithmetic mean and weighted arithmetic mean. And in the case of simple arithmetic mean, we all know that there are equally important variables. Okay, so in the case of simple arithmetic mean, all variables have equally importance. Okay, so now going to the second one, that is the weighted. So now move on the next slide. So here we can see in the case of weighted arithmetic mean, it refers to the average when different items of a series are given different weights according to their relative importance. That is the basic differences between the simple arithmetic mean and weighted arithmetic mean. In the case of simple arithmetic mean, there are equally important variables, but in the case of weighted arithmetic mean, there are different importance. All variables have different importance, different weights according to their relative importance. That is the basic differences between the simple arithmetic mean and weighted arithmetic mean. So now going to the formula. So weighted arithmetic mean is equals to summation wx divided by summation w. So w denotes the weight. Okay. So now going to the next slide, where we can see the example. Okay. So here we can see the 50, 60, 80, these are the variable of x, and these are the weights according to their variable. Okay. So for the formula we have to calculate wx, because the formula is summation wx divided by summation w. So wx means the multiplication value between weight and the variable x. For the first subject, that is English, the x variable is 50 and weight is 2. So that's why wx is the 100. Now going to the second one, 60 into 2, that is equals to 120. Now going to the third one, 80 plus 4, that is equals to 320. 75 into 1, that is equals to 71, and 55 into 2, that is equals to 110. So that means summation wx means sum of all wx values. So that is equals to 7 to 5, and summation w is equals to also 10. So x bar equals to summation w x by summation w. So 7 to 5 divided by 10, that means 72.5. So which is the answer of the weighted arithmetic mean for this example. Okay. So now going to the next slide. So here we can see some merits of the arithmetic mean, and we have already discussed the characteristics of the arithmetic mean, and which is so similar to the merits of the arithmetic mean. So now going to the first one. The first one is the certainty. So we all know that arithmetic mean is the rigidly defined. So rigidly means there is no confusion. Okay, so it is rigidly defined by the algebraic formula. Now going to the second one, that is it is based on all observations. We all know that the basic formula of the arithmetic mean. So summation x divided by n. So n is equals to number of observations. So summation x means sum of the all values of the x variable. So I think this is clear why we called arithmetic mean is based on all observation. And now going to the third one, that is the simplicity. Yes, obviously arithmetic mean is easy to calculate and easy to understand. Okay, so now going to the fourth one, that is the algebraic treatment. So obviously arithmetic mean is capable of being treated mathematically, hence it is widely used in the statistical analysis. So fifth merits of arithmetic mean, that is the stability. Okay, stability, it is least affected by the sampling fluctuation. So it has sampling stability. Now going to the last one, that is the basis of comparison. Obviously arithmetic mean helps to compare the results between groups and within groups. Now going to the next slide, where we can see some demerits of the arithmetic mean. So now going to the first one. The first demerit is it is affected by the extreme values. I think this is clear when we are using an example. So we for example we have data for the measurement of the arithmetic mean like 5, 10, 15 and 90. So 90 is the extreme value. Okay, so 5, 10, 15 and 90. So 90 is the extreme value. So without 90, the arithmetic mean is equals to 5 plus 10 plus 15, which is equals to 15 plus 15, that is equals to 30, 30 by 3, which is equals to 10. But when we have to add the extreme values, that is 90, so 30 plus 90, which is equals to 120, and 120 is divided by 4, because there are 4 variables. So the arithmetic mean is 120 by 4, that is equals to 30. So I think this is clear when there is an extreme value, how much affected the arithmetic mean, how much affected the actual value of the arithmetic mean. Okay, so now going to the second one. So problem in case of incomplete data. Obviously it cannot be computed in case of incomplete data, and it gives obviously absurd and illogical results, and if any one of the data is missing, then mean cannot be calculated. Okay, so now going to the third one. So mean value may not figure in the series, so it can neither be determined by inspection or by graphical location. So graphical representation of arithmetic mean is not possible. Now we have already told that arithmetic mean cannot be calculated in case of incomplete data. So that's why it gives absurd or illogical results. And so now going to the fifth one, that is a misleading conclusion. Obviously arithmetic mean presents a misleading conclusions also, because when we have qualitative data like data on intelligence, honesty, smoking habits, or we have the incomplete data series, so that's why it gives absurd or illogical result to us. So that's why we can say the value of arithmetic mean will not help us to give the proper results or conclusions. I think these merits and demerits of the arithmetic mean are clear to everyone. Okay. So learner, we are done for the today's session. In this session, we have discussed the calculation process of arithmetic mean in the continuous series, and which is done by both methods, that is direct and shortcut method, and weighted arithmetic mean with its example and merits and demerits of the arithmetic mean. So we will describe another some important concepts of statistics in my next class. So till then stay tuned. If you have any query about it, please to comment in my comment section. And last but not the least, please do like, share, comments and subscribe to my channel. Happy learning. Thank you.